Okay, welcome back to the second day of the conference. I wanted to introduce a very special presenter from the vantage point of the Student Spaceflight Experiments Program. We are a 501c3 nonprofit, the National Center for Earth and Space Science Education. And whenever we do SSEP programs in a community, we've got to do this full cost recovery. Space is very expensive. And I can tell you just as a benchmark that the cost for the United States to send up one American astronaut to the International Space Station just went up. If we want to send an astronaut up, we have to pay the Russians $75 million. That's what it costs to send one human being to space and return them safely to Earth. And so for us to do the Student Spaceflight Experiments Program for a community, the cost, the real cost to do this is $23,000. And we work with many communities, even take the lead for many communities to find funds, a consortium of funders to get them aboard, because our job is to get as many students engaged in this program as possible, and we do not want funding to stand in the way. So we've worked tirelessly to try to find funding for communities, and the vast majority of communities, we actually found funding for them, and there have been communities that were able to bring funding to the table themselves. But one of the problems that we have is that whenever we try to find a consortium of funders for a community, it's typically done at the local level with companies and organizations that have a vested interest in providing some level of discretionary dollars to their community because they have a stake in their community participating. And it may very well be that we work really, really hard to find funding and we have a $2,000 or $3,000 shortfall. We've got all of the funding necessary for a community to come aboard except $2,000 or $3,000, and we're coming up on deadline for program start. And that's why the Center for the Advancement of Science and Space is such a remarkable strategic partner. Not only do we work with them to showcase the U.S. National Laboratory on the International Space Station, which they oversee at the behest of the United States Congress. So strategically, we are trying to showcase the research platform on ISS for, in this case, STEM education. But CASIS also provides $50,000 per mission to close budget shortfalls. And so if we have a few $1,000s that we just can't raise, I have the ability to allocate this CASIS discretionary dollars to fill that budget shortfall and get communities aboard. And I can tell you that, Patrick, I don't know how many, but I suspect on the order of 50 or so communities participate in this program because of CASIS. They're that important. And so with that, I have the distinct pleasure of introducing Patrick O'Neill, who is the Marketing and Communications Manager for the Center for the Advancement of Science in Space, and offer our sincerest thank you for making this possible for tens of thousands of students across the United States and Canada.
So I always find it funny when I have the opportunity to go and speak in more of a sciencey type form, because I'm the marketing communications guy. What do I know about science? I'm taking a look at the students right here, and you guys probably know more about science than I do. But I'm going to go out and try to walk through it anyway and give you guys an overview of the types of research experiments that are going up on the National Laboratory right now. So as Jeff alluded to, CASIS is the Center for the Advancement of Science and Space, and we have the opportunity to oversee the U.S. National Laboratory, and that's a pretty unique environment. When you sit there and you take a look at the International Space Station as a whole, and you take a look at the research that NASA does, which is absolutely incredible, and it's based on exploration, but there's a lot more that can be done. And so that's where kind of CASIS falls into that form. So some of the areas that we really focus on are life sciences, material sciences, physical sciences, technology development, and Earth observations. But the caveat associated with each one of those types of disciplines that we look at is that it has to have the potential to benefit life on Earth. So NASA and CASIS, everyone knows who NASA is, and most people have a decent understanding of what the types of research that NASA does on the International Space Station. So what they do is exploration-based. living, working in space, better understanding the human conditions so that we can do long-duration space flight, that we can go to Mars, that we can go to an asteroid, that we can go and become that Star Trekian type entity that we want to be one day down the road. And all of that is terrific. But there's a lot more that can be done on the space station, and that's how the National Laboratory came to be in the first place. Congress, in their infinite wisdom, said, you know what, NASA, you guys are doing a great job with exploration, but what else can be done? How can we basically commercialize the space station and open it up to a wide variety of users? So that's how the National Laboratory came to be. CASIS has been around now for just under 4 years, and as it says there, our mission is to increase the utilization of the ISS by other federal entities and the private sector to expand the U.S. economy in space-based research applications and operations. Effectively, what that means is that the Congress would really like for us to put a return on the investment for the billions of dollars that have been invested in the development and ultimate sustainability of the International Space Station. Okay, so let's talk about some of the science that's been going up through CASIS over the last couple of years. One of the areas that we have had the most activity, or I guess the area that we've had the most activity in, is life sciences. And a lot of this is derived from research that took place on the space shuttle back in the day. And being able to look and see how in a microgravity environment the variables change. And when you were sending research up on the space shuttle, most of the time it was just taking a look at things in a very fast turnkey manner. I mean, the shuttle's there for 2 weeks, then it comes back down. And the primary purpose of the astronauts when they were going to the space station at that time frame was more to actually build this space station. So any research that they did off to the side was something that was just kind of, let's take a look at it and see how it reacts, and then maybe one day down the road we have the opportunity to do more focused experimentation. So that's where we're at now. A lot of research that happened previously was focused on life sciences, and we were able to see that in a microgravity environment, once again, the variables change drastically. And now that we have the National Laboratory, we are in a position to do far more focused research, whether that be through drug development, taking a look at disease models, cell biology, and we'll get into some of the experiments that have gone up right now. So protein crystal growth is something that it's something that's been going around, I guess, for about 20 or 30 years when it comes to space-based research. And effectively what ends up happening is that you can do larger, more highly ordered crystals in a microgravity environment. And that is of critical importance in particular when you're talking to life scientists so that they can better attack disease. And you can see kind of the picture right there. Taking a look at a crystal in a gravity-filled environment on Earth, it's fractured and it's kind of fragmented all over the place. And then you take a look at a crystal, how it can look in a microgravity environment. And this is actually a very old picture. One of our investigators, Joe Ng from the University of Alabama, Huntsville, is going to be publishing papers that are associated with protein crystal growth experiments that they did. And the crystals that they got are very, very unique as well. And so from that, hopefully you're able to really kind of play with membranes and really kind of expand the limits of what we know when it comes to drug development and therapies. And to date, we've worked with a variety of users. So our very first solicitation was focused on protein crystal growth, and we ended up funding 7 different investigations. One of them was from Caltech, and it was focused on Huntington's disease. But a lot of other protein crystal growth experimentations were focused on things like, I want to say, Parkinson's syndrome, cystic fibrosis, a lot of the debilitating diseases that are really hindering life on Earth right now. And from that, we are actually expecting to have a lot of published results in the next few months. One of the areas, too, that is, I guess, fun to talk about, but at the same time, one that NASA does not necessarily like to publicize too terribly much, is the idea of rodent research. And rodent research is something that has become a new fad, if you will, for CASIS and for a lot of the investigators that we are working with. Effectively, as a lot of you might know, once you get in a microgravity environment, your body just starts to deteriorate and age rapidly. And when you have a rodent research habitat, for instance, I guess the average rodent lives in the neighborhood of 2 to 3 years. So you can put these rodents in a microgravity environment for 30 days to a few months, and that could be the vast majority of their adult life. And if our bodies deteriorate rapidly in a microgravity environment, imagine what it's going to be like for a rodent who has a far shorter lifespan. So when you're talking to pharmaceutical companies, for instance, does anybody know by chance how long it takes to get an average drug from conception to the market? About 10 years and about $1 billion. So what we like to call is quick-to-fail methods, and that's what rodent research on the space station can do. If you are in a position to, through 30 days of research on a rodent, be able to take off a couple of years of experimentation that might end up having to take place on the ground, then that's something that a lot of pharmaceutical companies are very interested in because it allows them, A, the innovation opportunity, but B, it allows you to go out and save a heck of a lot of money that otherwise we'd have to put into the product. So as of right now, we are working with Novartis, which is a very reputable pharmaceutical company. They have sent 2 separate rodent research investigations to the space station. And then we are also going to be working with Eli Lilly. They are another Fortune 100 pharmaceutical company that's going to be sending rodent research up. It looks like it's going to be SpaceX 8, but obviously with what happened on Sunday, I guess we're going to reevaluate that a little bit later down the road. Also, hopefully later on this year, stem cells. I mean, stem cells is kind of a buzzword, I guess, within the life science community. And CASIS decided that we wanted to go and put forth the $2 million in grant funding. And we have funded 7 different investigations that will have the opportunity to now utilize the space station so that they can better look at tissue growth and gene expression. And again, most of the individuals that are taking advantage of a microgravity environment focused on stem cells research is dedicated towards better understanding disease. So life science, while that is something that has been of utmost importance to us, that's not all we do. Material science, physical science are also, they are proving to be very fruitful. And the argument that I make oftentimes is life science investigations, you know, as the question was alluded to, how long does it take to make something go from conception to market? 10 years, and hopefully we'll be in a position to expedite that ever so slightly. But the other side of the coin, too, is material science and physical science technology development. A lot of that could be very, very fast, very turnkey. Basically, what you do on the space station today might be something that you could put to market next year. And I'll give you an example of that in just a second. But as you can see there's everything from diffusion, combustion, radiation, vacuum. All of those are variables that investigators are interested in looking at when it comes to space station research. So, golf clubs in space. Anybody else here play golf besides me? All right, well, you know, the good news is that Cobra Golf is interested in trying to make sure that you have the world's most innovative golf club in your hand so that your slice goes away. You're like, there's no such thing as a slice with me. It's straight, right down the middle, huh? Yeah, you and me both. But anyway, so Cobra Golf last year, they sent research to the space station that was looking at electroplating, dissimilar metals, and the thought process, again, was so that they could have a more durable, but also higher performing golf club. And it's pretty interesting when you think of the space station as a potential catalyst for driving market innovations. And that, again, is kind of why it was the CASIS was created in the first place, is the opportunity to open up the doors and allow commercial entities to take advantage of a space station or a microgravity environment maybe otherwise they never would have thought about. And our friends over at Cobra, it's not lost on them, too, the marketing potential that is associated with not only doing research on the space station, but being able to say that we did research on the space station and that that is completely different from what our counterparts are doing. And that allows you the opportunity to potentially get a new market base. So I would say later on this year, you might want to look out for some space-aged golf clubs. Other things that we're dealing with right now. So better prosthetics through microgravity research. We recently awarded an investigation and it flew up on SpaceX 6, I want to say. And it was focused on, synthetic muscle design. But the idea was to look at electroactive polymers to see how it is that we might be able to better enhance products or prosthetics not only on the ground, but potentially have applications for better robotics when it comes to helping research on the space station. So that's something that I guess is also an interesting opportunity because it has both that life, benefiting life on Earth component, but also something that has the potential to enhance exploration endeavors for NASA. And then lastly, Procter & Gamble, they send complex fluids to space. So they were looking at colloidal materials to ultimately better their products. So Procter & Gamble, think of shampoo or lotion, stuff like that. You can actually use a space station to create a better product associated with that. Go figure. And this is something that a lot of youngsters are really excited about is the idea of you can actually now do 3D printing in a microgravity environment. Last year, NASA granted a company by the name of Made in Space to send the first 3D printer to the International Space Station. And the thought process behind that was twofold. One, if something breaks on the space station, say for instance a wrench, and you don't have an extra wrench, it might be a few months until you get an opportunity to have that wrench be sent back up to you. It would be really awesome if you could be able to make a wrench in a microgravity environment, and that's what the 3D printer is allowing NASA and the astronauts to do. But secondary to that, it also opens up that commercial element once again. How can you develop things in a microgravity environment? Can you develop manufacturing chains? Or every now and then, can you just develop cool doohickeys that were just based in space, and then you could send it back, and then Made in Space could sell it for a profit? So, commercializing space one day at a time. CASIS works with a variety of users, and it doesn't matter if you are an academic institution, a Fortune 100 company, or if you're somebody that just has a crazy idea that you designed out of your basement. If it's a good idea and it's something that is operationally feasible, has scientific merit, and has the potential to benefit life on Earth, it's something that we will ultimately consider sending to the space station. And most importantly, when you're talking to commercial companies, the first question they ask is, how expensive is it to send research to the space station? They're thinking it's going to be millions of dollars. But by sending your research up through the National Laboratory, flight, astronaut crew time are all assumed. So that ultimately saves the commercial entity, or any researcher for that matter, in excess of $7 million that they don't have to worry about. It's actually an interesting little sidebar too, that the astronaut crew time, they've kind of looked at the numbers associated with that. For an astronaut to do 1 hour worth of work on your investigation equates to $70,000. So that's a pretty good year right there. So once again, that's kind of the commercial element of what we are doing, but again, we work with some of the top academic institutions in the nation, whether that be UCLA, Stanford, Miami, Texas A&M, MIT, but also, as we're looking out here today and why I'm talking with you, is we do a lot when it comes to STEM education, because ultimately it's trying to inspire that next generation of scientists and engineers and allow them the opportunity to realize that microgravity, or gravity I should say, should not hold you back. So again, that's kind of a little breakdown of some of the commercial companies that are sending research up. And at this point in time, I will open it up to any questions that anybody might have relative to the National Laboratory or research that we are conducting. Oh, by the way, don't forget to be socially active with us and follow us on Twitter as well as on Facebook and all the other cool social elements. Thank you.
Good morning. I'm Tom from Santa Ana, California. I was just wondering, do you prioritize the potential research by how beneficial it will be to mankind, or is it kind of who has the most funding to offer for the research?
That's a great question. I would say that there's two parts to that. We do have the ability to fast track some projects, but a lot of it also deals with the size, volume, will it incur astronaut crew time, etc. So those are all things that we ultimately have to work with NASA on. So again, we get 50% of the astronaut crew time, they get the other half. And the other side of the coin too is, how big is the experiment? So there's a lot of variables that come into play. But I would also say that, again, there is the opportunity or the capacity for us to fast track some projects depending upon the importance of it or the potential opportunity associated with it.
Thank you.
And let's thank Patrick one more time.
Thank you.
And I think that what was very exciting is that all of the student researchers that have done this program, the curriculum addresses all of the different science disciplines appropriate for microgravity research. And you can see that Patrick was able to show how industry, commercial companies, are interested in things like protein crystal growth and life sciences, those things that you all studied as part of the SSEP curriculum. So, SSEP really is an extension of actual professional research that's ongoing on station, and that's a great thing to be part of. Thanks again, Patrick.